Hi and greetings to everyone. Me and my teammates are going to explain the walking boot as a biomedical device for our subject, statics and mechanics. So firstly, what is a walking boot? Walking boot is an orthopedic device that protects the foot and ankle after an injury or a surgery. A specialized footwear for ankle sprains, fractures, and shin splints. The purpose of this device is to add stability to your foot as you move. The weight of the boots will hold the foot in place so that you can prevent any further injuries. The difference between the cast and this walking boot is that the cast immobilize the foot, while these boots facilitate mobility by gradually putting the weight on the injured leg. One of its strong points is its flexibility. It is designed with straps and inflatable compartments to fulfill different leg shapes and sizes. The boot can be adjusted and removed whenever the user likes it, and it is very convenient. This level of adjustability ensures comfort and satisfaction for users. Now, there are various versions of these walking boots, but I mainly cover three of them, which are controlled ankle movement, CAM, air cast, and also hard cast bottom shoes. Now, the CAM boots are for severe injuries as they are heavier than air cast and come in rocker bottom for natural walking. For the hard cast bottom are designed to fit around the ankle area only, while the air cast covers the area below the knee. So this level of versions of this walking boot adjusts and gives comfort for the patients.
Hi, my name is FAHMI IMRAN, and today I will be explaining about the dimension and material of the boot. The walking boot is made to be adjustable to a certain extent to expand the number of users regardless of their foot sizes. The chart shown here is the sizing used by most men in the world. Considering the average male foot size, through various sources and data collected worldwide, we have come to conclusion that average male foot size is between 9 to 12 US, which has a heel to toe length of 26 to 29 cm. Average male foot size is between 9 to 11 cm, and the maximum circumference of their feet is between 24 to 28 cm. And the shell thickness of this boot from the ankle to toe region is around 0.8 cm, while the rest of the shell is around 0.1 cm. Next, for the material part. One of the most important characteristics of the ankle boot support is that it must be light enough to be able to carry around with less effort, while still maintaining a very solid structure to provide support for the ankle. To precisely follow those characteristics, we have chosen the most suitable materials for the ankle boot. First, for this shell, we will use polypropylene. For the straps, we will use nylon. For the outer sole or insole, we will use either rubber or EVA, which stands for ethylene vinyl acetate. And last but not least, for the lining, we will use either nylon, polyurethane or polyester. Polypropylene is a commodity plastic with low density and high heat resistance. It is a type of polyolefin that is slightly harder than polyethylene. It is also widely used in packaging, automotive and medical cars. The density of polypropylene is between 0.895 and 0.92 grams per cubic centimeter. The parts made from it will have an exceptionally low weight while still maintaining the strength and rigidity of the structure. Polypropylene structure has a good tensile strength that is around 4,800 psi, which is equivalent to 337.5 kg per centimeter square. This allows the material to withstand heavy loads despite being lightweight. The compressive strength of this material is also incredible, which can go up to 40 megapascal or around 407.8 kg per centimeter square. This kind of characteristic is enough for us to choose polypropylene as the material for the shell of the ankle boot support. Now, these are some of the examples of products that also are mainly made by polypropylene.
So to calculate the weight of the ankle boots, we use the density of polypropylene and also the density of the rubber soles. So the volume of the shell, which is made up of polypropylene, is 1180.6 cm cube, while the volume of the soles is 223.3 centimeter cube. Using the formula of density, which is mass over volume, the total mass of the shell is 1.057 kilogram, and total mass of the sole is 0.0201 kilogram. So we also estimate the mass of the fabrics and the insole used inside the ankle boots. So which add up to total mass of the boots is 1.5 kilogram.
Hello, my name is Muhammad HAZIQ bin FADZIL ANUAR 22002069, and today I will explain about free body diagram. So free body diagram represents the relative magnitude and direction of all forces acting on the walking boot. So it will tells the effect of the external force on that walking boot. So as you can see from the diagram, there are 5 forces acting on the boot. So the force upward is the normal force, and downwards we have the weight of the boot and also weight of an average man. And moving to the x-axis direction, there is the force acting forward and another force acting backwards, which is the friction. Based on our calculations, we found out that the friction between the concrete and also rubber of the boot, the friction is 429.68 Newton. Let's look at the stress and strain acting on the ankle boot. So given the stress modulus of the ankle boot is about 40 megapascal, and the area is 8.648 times 10 negative to the power of negative 3 meter squared, and the formula is Fmax is equals the stress modulus times the area. So the maximum force we will get is about 345.92 kilonewton, and the strain, in order to calculate the strain, it is stress over the elastic modulus. So it's 40 over 1325, we will get 0.0302, and in order to get the maximum deformation, we can use the formula strain over the changes of the volume over the volume. We will get 2.0894 times 10 to the power of 86 meter cube. Let's look at the torsion acting on the ankle to shin area. So given the maximum shear stress is 3 megapascal, and now we can use the formula of T max equals TC over J. So by putting all the inputs that we have, and we can obtain that the max torsion that we get is 365.93 Newton meter.
So moment of inertia. Moment of inertia is a measure of an object's resistance to changes in its rotation. Based on the simple diagram that we draw, we conclude that the boots is a simple composite structure that is made up of two components. So we must use a parallel axis theorem to calculate its moment of inertia. We must sum up of all the moments of inertia of its individual components. So for the calculation to find the moment of inertia, we use the parallel axis theorem. We find the moment of inertia in plate 1 and also the moment of inertia in the plate 2. And also we sum up of the moment of inertia and we get 1.563 times 10 power of negative 3 meter power of 4. So for the centroid of the structure, the formula is kx is equals to square root of moment of inertia over the total area of the structure. So we got the centroid is 0.14535 meter. So for the moment that is acting on the boot, moment refers to the tendency of a force to rotate an object around an axis. It is calculated as the product of the force and the perpendicular distance from the force to the axis of rotation. This moment is sometimes called a bending moment. So from the diagram of the structure, we conclude that the axis of rotation is either on the heels of the boots or on the toes of the boots. So we assume that the perpendicular forces that is acting uh, against the boots is normal force, which we assume is happening at the center of the soles. So by using the information that we have, we calculate the moment using the formula, which is moment is equals to force times the distance of the force from the to the axis of rotation or moment arm. So we get negative 62.3036 Newton meter.
Hi, my name is ABDUL bin Muhammad Nizam, meets matrix number 22001377. So one of the main advantage of this walking boot is its adjustable size. It's offering user a comfortable fit and excellent air circulation. So this feature is contributes significantly to the user, more comfort and promoting a more positive experience during the recovery process, especially for those who are face injuries. So the materials. The key material used in the manufacturing process include polypropylene, nylon, rubber, ethylene vinyl acetate, polyurethane, and polyester. Each material serves a specific purpose with a primary focus on providing optimal ankle support. Importantly, these materials are user-friendly and easy to use and do not cause allergies or negative effects on sensitive skin. Next, the walking boot excels in redistributing load and pressure, reducing forces on the foot or ankle for user. This not only enhances stability but also contributes to a more efficient recovery process for the patient. The design and material work in tandem to ensure maximum support for patients undergoing rehabilitation and recovery process. To gain a deeper understanding of the forces, biomedical engineers use tools such as free body diagrams to help them for calculation. This diagram help in identifying all the reaction forces faced by the walking boot. To make it easier to calculate the key parameters like the moment of inertia, torsion, stress and strength of the materials. All these factors contribute to the mechanics of the walking boot, especially when it's in static position. So, last but not least, a specialist in biomedical engineering may propose updates to the walking boot, incorporating electronic components or a premium materials to enhance its functionality further. This continual improvement in design and materials ensure that the walking boot remains at the forefront of biomedical innovation. Thank you.